Hello everyone. Today we are going to see what is cluster analysis. Cluster is a collection of data objects similar to one another within the same group and dissimilar to objects in the other group, which means it is a collection of data objects which are related to each other or which are similar to each other grouped as a single cluster. These data objects which have been grouped as a single cluster will be related to each other in that particular cluster, whereas it will be different from the other clusters. So cluster analysis is finding similarities between the data according to the characteristics found in the data and grouping similar data objects into clusters, which means we are going to have a data set. So in this data set, we are going to find the similarities based on the characteristics. If we are going to find any data which is having the similarities based on the characteristics which we are considering, then we are going to make a group of such data and we are going to call it as a single cluster. Here, the data which we are choosing is of similar kind. If they are not similar, like the data which we have selected is not having any similarities with the characteristics which we have considered, then we are going to group it as different clusters or individual clusters. This cluster is unsupervised learning, which means no predefined classes are available for this. This unsupervised learning is learning by observations, whereas the supervised learning is learning by examples. In supervised learning, we are going to know exactly what input has to be given and what will be the output of this particular input. When such things is known to us, we call it as supervised learning. If that is not known, that is if the predefined classes are not known to us, we are going to call it as unsupervised learning. The typical applications of this cluster analysis are: you can use this cluster analysis as a standalone tool to get the insight into data distribution, like as to how the data has been distributed or what is the similarities which can be found by the data sets and so on. Or you can use this as a pre-processing step for another algorithms. So different algorithms will be there you can use as a pre-processing step for that. So clustering for data understanding and applications. What is cluster where are these clustering used? Cluster is a collection of data objects similar to one another can be used in the fields like biology, dissimilar to objects in the other group. Land use, marketing, is a collection of data objects which are related to each other and so on, or which are in biology we have grouped as a single cluster. These data objects which have been grouped as a single cluster will be so whenever we are doing all these things or this classification, whereas it will be different from the other clusters. So cluster analysis is finding similarities between the data according to the characteristics found in the data. We are going to and grouping similar data objects into clusters, which means we are going to have a data set. It will be having wings. So in this data set, we are going to find the similarities based on the characteristics. If we are going to find any data which is having the similarities based on the characteristics which we are considering, we are going to classify it as we are going to make in the same group of such data we are going to do this for it as a single cluster. So this here how the data which we are choosing is of in information retrieval. We can use this for document clustering. Like the data which so identification of areas of similar land use in Earth observation with the characteristics which we have considered can be an application of clustering in the land use as different you can help marketers discover distinct group in this cluster basis and then use this knowledge to develop targeted marketing predefined classes are available for this. And all those unsupervised learning can be used or clustering can be used in marketing as an example. Whereas so in the city planning, identifying groups and houses according to their house types, in supervised learning, value and geographical locations, exactly what input has to be given and what will be the output of this particular should be clustered. When such things is known to us, we call it as supervised learning. So climate, if that is understanding not known, the Earth's that climate, is if the predefined classes are not known to us, we are going to call it as unsupervised learning. The typical applications of this cluster analysis are: you can use this cluster analysis as a standalone tool to get the insight into data distribution. It is not limited to how the data has been distributed or what is the similarities which can be found by the data sets and so on. So what are the considerations? You can use this as a pre-processing step. So we are going to consider partitioning criteria. So different algorithm clusters you can use as a pre-processing step as the considerations for this cluster analysis. Today we are going to see what is cluster analysis. Cluster is a collection of data objects similar to one another in the separation of clusters. We look for dissimilar to objects in the other cluster, which means it is a collection of data objects which are related to each other or which are similar to each other
If it is
grouped as a
distance-based
single
clustering,
cluster.
we will be
These
looking out for
data objects
Euclidean
which have been
distance, road
grouped as a
network,
single
vector,
cluster
and
will
any
be
distance measure
related to
algorithm which
each
you
other in
consider.
that particular
In
cluster,
the
whereas
connectivity
it will
base,
be
we are going
different
for
from the other
density-based
clusters.
clustering or
So, cluster
contiguity-based clustering.
analysis
So
is
clustering
finding
spaces, whether
similarities
it is a
between the
full
data
space
according to the
clustering or
characteristics
subspace
found in the
clustering,
data
we are going to
and
check it out.
grouping similar data objects into clusters, which means
So
we
we
are
came
going
to
to
know the
have a data set.
considerations. Now we are going to check out
So
what are
in
the
this data
requirement
set, we are
and
going to find
challenges
the
for this
similarities
clustering analysis.
based on the
The basic
characteristics.
requirement or
If we
challenges
are
for
going
this
to find
clustering
any
analysis
data which
is
is having the
scalability.
similarities based on
Clustering
the
all data
characteristics which we are
instead of
considering, then
only
we
on
are going to
samples.
make a
So
group of
instead of
such
selecting
data and
samples,
we are
if
going to
we
call
are
it as
going
a
to make
single
this
cluster.
clustering for
Here,
all the
the
data,
data which we
whether
are
the
choosing is
clustering
of
analysis
similar
is
kind.
scalable
If
or
they are
not.
not
That is the
similar,
major
like the
challenge which
data
we
which
have.
we have selected
If we
is not
consider
having any
any huge
similarities
data set
with
and
the
if we are
characteristics
performing
which
the
we have
cluster
considered,
analysis, and
then
if it
we
is
are
not
going to
scalable,
group it
then we are
as
not going
different
to use that.
clusters or
So
individual
for any
clusters.
cluster
This
analysis or
cluster
clustering
is
technique,
unsupervised
scalability
learning,
is one of the
which means
important
no
requirement or
predefined classes
challenges.
are available for
Next
this.
is
This
ability to
unsupervised
deal with
learning is
different types of
learning by
attributes.
observations.
Dataset might have different types of
Whereas
attributes like
the
numerical
supervised
attribute,
learning is
binary,
learning
binary
by
attribute,
examples. In
categorical
supervised
attribute,
learning,
ordinal,
we are
linked,
going to
and
know
mixture of all these things
exactly
might be
what
there.
input has to
Or
be given
it
and
might be a
what will be
homogeneous
the
data
output of
or
this
it might be
particular
a
input.
heterogeneous data.
When such things is
Whenever it
known
is
to us,
also
we
a
call it as
heterogeneous data,
supervised
this
learning.
clustering analysis
If
has to
that is
be
not known,
working
that
fine
is,
with
if
it.
the
If
predefined
it is
classes
not
are
working
not
fine,
known to
then
us,
we cannot
we are
use
going to
that
call it
clustering
as
analysis
unsupervised
technique.
learning.
So
The
in order
typical
to do this,
applications of
we
this
have to
cluster
have
analysis
a
are:
clustering
you can
technique
use this
or
cluster
clustering analysis
analysis as a
technique
standalone
which
tool
has an
to get the
ability to deal
insight into
with
data
different types
distribution,
of attributes.
like as to
Even
how the data has
given
been
different
distributed
attributes
or
in a
what is the
single data set,
similarities
it
which
has
you
to
can be
be
found by
able
the
to
data
take
sets
up
and so
all
on.
the
Or you
attributes
can use
and
this as a
it has to
pre-processing
cluster it
step
properly.
for another
Next is
algorithms. So
constraint-based clustering.
different algorithms will
User
be
may
there you can
give
use
inputs as
as a
constraints,
pre-processing
use
step for
domain
that.
knowledge to determine input
Hello
parameters,
everyone. Today we are going to
interpretability
see
and
what is cluster
usability.
analysis.
Here,
Cluster is a collection of
clustering
data objects
can be
similar to one another
constraint-based.
within the same group
Like,
and
I'm going to
dissimilar
give
to
a
objects
specific
in the other
constraint
group,
for my
which
dataset
means
to
is
cluster.
a collection
If
of data objects
it
which
can
are
cluster
related to
in the
each
way I
other
want,
or
then
which
it
are
is very
similar
much
to each
useful for
other
me. It
grouped
works
as a single
as
cluster.
IC.
These
So
data
in this
objects which
way,
have been
user may give the
grouped as a
inputs as
single
constraints.
cluster will
Whenever
be
user gives the input as
related to each
constraints,
other in that
even
particular
then,
cluster,
if the clustering
whereas it will
analysis
be
works fine,
different
then
from the
it's good.
other clusters.
Use domain
So,
knowledge to
cluster
determine input
analysis
parameters.
is
Using the
finding
domain knowledge,
similarities between the
the
data
domain
according to
of
the
the data set
characteristics
which
found
we
in the
have,
data
we have to
and
use that
grouping
knowledge
similar
and
data
we have to
objects into
determine
clusters,
what are the input
which means
parameters
we are
which
going to
has to be
have a data
selected
set.
for the cluster
So,
analysis.
in this data set, we are going to
Interpretability
find
and
the
usability.
similarities based on
So
the
what is the
characteristics.
interpretability
If
and
we are
usability
going to
of this?
find any data
So
which
whether
is
it is
having the similarities
interpretable
based on
or
the
usable,
characteristics
we
which we
have
are
to consider
considering,
it, and
then we are
the
going to
cluster
make
has to
a
be taken
group
into
of such
consideration.
data and we are
Others,
going to call it
like
as a single
discovery of
cluster.
clusters within
Here,
arbitrary shape,
the data which
ability
we are
to deal with
choosing is
noisy
of
data,
similar kind.
incremental
If they are
clustering
not
and
similar,
insensitivity
like
to
the
input
data which
order,
we have selected
high
is not having
dimensionality.
any similarities
So
due
these
to
are
the
the requirements
characteristics
and
which we have
challenges for any
considered,
clustering
then
techniques.
we are going to
So
group it
major
as
clustering
different
approaches.
clusters or
So here we
individual
have
clusters.
partitioning approach,
This
we have
cluster is
hierarchical approach, we
unsupervised
have
learning,
density based
which
approach,
means
we
no
have grid based
predefined
approach.
classes are
These are
available
not
for
limited
this.
to this, but
This
there are
unsupervised
these are the
learning
main things
is
which we'll be
learning by
concentrating here.
observations,
Partitioning approach. We are going to
whereas
construct
the
various
supervised learning
partitions and
is
then
learning by
evaluate them by
examples. In
some
supervised
criteria,
learning, we
like
are going to know
minimizing the sum of
exactly
square
what
errors
input has to be given and
is one
what
of
will
the
be the
examples
output of
which
this
can be taken
particular
for this
input. When
partitioning
such things
approach.
is known
Like
to
we are
us,
going
we
to
call
have
it
a
as
data set,
supervised
we are
learning.
going to divide it
If
into
that is
chunks
not known,
and
that
we are
is,
going
if
to
the
evaluate
predefined
it
classes
based
are
on some
not known to us,
criterion.
we are
If we are
going to
doing
call
this,
it as
we call it as
unsupervised
partitioning
learning.
approach.
The typical
Hierarchical
applications of
approach.
this cluster analysis are:
The
you
examples, the
can use
typical
this
methods which
cluster
are used in
analysis as a
partitional approach
standalone
is
tool to get the
chainings,
insight into data
medoids,
distribution,
clarans.
like as to how
So
the data
hierarchical
has been
approach. Create a
distributed or
hierarchical
what is the
decomposition
similarities
of
which
the
you
set
can be
of
found
data
by the
or
data
objects
sets
using
and
some
so on.
criteria.
Or you can
The
use this
typical
as a
methods here
pre-processing
used are
step for
diana,
another algorithm.
vagueness,
So
birch,
different
and
algorithms will be there
chameleon.
you can use as
Density-based
a
approaches.
pre-processing step.
Based on the connectivity and the density
Hello
functions, we are
everyone.
going to have
Today
this
we are going to
density-based
see what is
approaches.
cluster
Typical
analysis.
methods are DB
Cluster
scan,
is a collection of
optics,
data objects
dense loop,
similar to
etc.
one another within
So
the same
grid-based
group
approach
and
based on a
dissimilar
multiple
to
level
objects in the
granularity
other group,
structure.
which
This
means
grid-based
it is a
approach is
collection
based on
of
the
data
multiple
objects
level
which are
granularity structure.
related to each other
Typical methods are
or which
string,
are similar
wave
to each
cluster,
other
click.
grouped as a
So
single cluster.
These are the
data
major
objects
clustering
which have been
approaches which can be
grouped
used
as a
or which can
single
be
cluster
concentrated on
will
while
be
taking up this
related to each other
clustering.
in that particular cluster,
So
whereas it will
partitioning
be different
algorithms.
from the other
What is this
clusters.
partitioning
So,
algorithms?
cluster
Partitioning method.
analysis is finding similarities between the data according to the
Partitioning a
characteristics found in the
database
data
D of n
and
objects into
grouping
set of
similar
k
data
clusters
objects
such
into
that the
clusters,
sum of square
which means
distance is
we are going
minimized.
to have a data set.
Given
So
k,
in this
find a
data set,
partition
we are
of
going to
k
find the
clusters that
similarities
optimizes the chosen
based on the
partitioning
characteristics.
criterion.
If
Global
we are going to
optimal,
find
which
any
can be
data
called
which
as
is having the
exhaustively,
similarities based on the
exhaustively
characteristics which we are
enumerates
considering,
all
then
partitions.
we are going to
Heuristic
make
methods,
a group of
k-means
such
and
data
k-medoid
and we are
algorithms.
going to call it as a
K
single
means each
cluster.
cluster is
Here,
represented by the
the
center of
data
clusters.
which we are
So
choosing
here
is of similar
we
kind.
are going to
If they are
partition
not
a
similar, like
database
the
D,
data which we have
which is
selected
having n
is not having
objects,
any
into the set of
similarities
k
with
clusters.
the
K
characteristics
is the
which we
number,
have
arbitrary
considered,
number which we are
then we are
selecting
going
here,
to group
like
it as
whatever the
different
complete
clusters
data
or
set we have. We
individual
call it as a
clusters.
database.
This
D
cluster
is a
is
database. This
unsupervised
D
learning, which means
database
no
contains n
predefined
number of
classes are
objects,
available for
or
us.
there are n different
This
objects in a
unsupervised
given
learning
database.
is
Now
learning by
we are going to
observation,
have the database,
whereas
the
the
data in the
supervised learning
database
is
to be
learning by
clustered into
examples.
k
In
different
supervised
clusters,
learning, we are going to know
such that
exactly
the sum
what
of the
input has
squared
to be
distance
given
is
and
minimized.
what will be
The
the output
distance
of this
between those
particular
2 points
input.
is
When such
minimized.
things is known to us, we call it
How
as
we are going to do
supervised
that? We
learning.
are going to find
If
out a
that is
centroid
not
or a
known, that
medoid
is,
of a
if the
cluster.
predefined classes
So
are
given a
not known
cluster,
to
we are
us,
going to
we
find
are
the
going to
centroid
call
of
it
the
as
cell.
unsupervised learning.
Based on
The
this
typical
centroid, we are going to
applications of
do
this
as
cluster
a k
analysis are
cluster
you can
partitioning
use this cluster
for
analysis
all
as a
the n
standalone tool
values of
to
the
get the
given
insight
database
into
D.
data distribution,
Given k,
like
find a
as to
partition
how
of
the
k
data has
clusters
been
that optimizes
distributed
the
or what
chosen
is the
partitioning
similarities which we
criterion.
can be found by the
So we
data
are going
sets
to find out one
and so
global
on.
optimal.
Or
This
you can
global
use this as a
optimal
pre-processing step
exhaustively
for
enumerates
another
all
algorithms.
partitions.
So different
Heuristic
algorithms
methods
will be
like
there you can
k-means
use
and
as a
k-medoid algorithm
pre-processing
can
step
be
for
used.
that.
Each cluster is
Hello
represented by the
everyone.
center of the
Today we are
cluster.
going to see what is cluster analysis.
K-means clustering
Cluster is
algorithm.
a collection of
Given
data
k, the
objects
k-means
similar to one
clustering
another
algorithm is
within the same
implemented in
group
4 steps.
and
As
dissimilar
the
to
name says,
objects
we
in
are
the
going to
other group,
use
which
means
means
here.
it is a
K
collection
means
of
k is the
data objects
arbitrary number
which
of
are
clusters or
related to
cluster
each
groups
other
which you are doing,
or which are
and
similar
based on
to
this
each
we are
other
going to have this
grouped
algorithm.
as a single cluster.
Partitioning objects into
These
k
data
non-empty
objects which have
subsets,
been grouped as a
then
single
compute
cluster
seed
will
points
be
as centroids of the
related to each other
clusters
in
of the
that
current
particular cluster,
partitioning.
whereas it will be
Centroid
different
is
from
the
the other
center,
clusters.
that is
So,
mean point
cluster
of the cluster.
analysis is
Assign
finding
each
similarities
object
between the
to the
data
cluster
according to the
with the
characteristics
nearest
found in the
seed
data
point.
and
Go back
grouping
to step
similar
2.
data objects into
Stop
clusters,
when the
which
assignment
means
does not
we are
change.
going to have a
So
data set.
here initially we are going
So,
to
in
have
this data
k
set, we are going
non-empty
to find the
sets,
similarities
non-empty subsets. It
based
might
on
be
the
of individual
characteristics.
objects
If
also.
we are going to
Next
find
we are
any
going to
data
compute
which
the
is
seed
having the
points as
similarities
centroids
based
of
on
the
the
clusters.
characteristics which we are considering,
This seed points is
then
nothing
we are
but
going to
some
make
point in the
group
cluster
of
wherein
such
which it is
datas
very
and we are
near
going
to
to
the
call it as a
neighboring
single
data
cluster.
set or data
Here,
object.
the data
So we
which
are
we are
going to
choosing is
group
of
them together.
similar kind. If
We are
they are
going to
not
assign each
similar,
object
like
to a
the
cluster with
data
the
which we have
nearest
selected
seed point.
is not having any
And then we are
similarities
going to do the
with the
second
characteristics
step,
which we
like
have
computing the
considered,
seed points,
then we
until
are going
the
to
assignment
group it
does not
as
change.
different
This
clusters or
k-means clustering, we
individual
have a
clusters.
problem which can be
This
solved.
cluster is
I'll
unsupervised
be thinking
learning,
of this
which means no
k-means clustering
predefined classes
problem in
are
the next
available for
video.
us.
So
This
we'll
unsupervised learning
go into
is
deeper there.
learning by observations,
So this
whereas
k-means is
the
having one
supervised
few
learning is
problems.
learning by
Is
examples.
sensitive
In
to
supervised
outliers.
learning,
This
we are
k-means
going to know
algorithm is sensitive
exactly
to
what
outliers.
input has to be
Since an
given
object with an
and what
extremely
will be
large
the output
value
of
may
this particular
substantially
input.
distort
When
the
such things
distribution
is
of the
known to us, we
data,
call it as
we can
supervised
also use this
learning.
k-means.
If that is not known,
K-medoids.
that is,
Instead of
if the
taking the mean
predefined
value of
classes
the
are
object in
not
the
known to
cluster
us,
as
we
reference
are going
point,
to call it as
medoids can be
unsupervised
used,
learning.
which is the
The
most
typical
centrally located
applications of this
object in the
cluster
cluster.
analysis are
So in the
you can
diagram we
use
can
this
see,
cluster analysis as a
instead of
standalone tool to
putting
get
it
the insight
instead of
into data
scattering it like that,
distribution,
we are
like
going to
as to
group
how
it
the
based on the
data has been
centroids or the
distributed
medoids which
or
can be
what is the
used.
similarities
So
which we can be
hierarchical
found by
clustering.
the data
So
sets
here in this
and so
hierarchical
on.
clustering,
Or
we are
you
going
can
to
use
make
this
use
as
of
a
distance
pre-processing
methods as a
step for another
clustering criterion.
algorithms. So different
This
algorithms will be there you can use
clustering
as a
technique does does
processing
not
step.
require the number of clusters k
Hello
as an
everyone.
input,
Today we are
but
going to
it
see
needs a
what is
termination
cluster
condition.
analysis.
Here you can see in the
Cluster
diagram
is
we
a
have
collection of data
agglomerative and
objects
divisive
similar to
techniques.
one another
So
within the same
agglomerative
group
technique
and
is a technique
dissimilar to
which
objects in the
starts
other
from
group,
the
which
basic
means it
single
is a
object
collection of
as its
data objects which are
cluster.
related to
Like
each
if
other
there are 5
or
different
which are
objects
similar
like
to
A,
each
B,
other
C, D, E,
grouped
each
as a single
object
cluster.
is
These data
considered as a
objects which have
cluster.
been
Then
grouped
we
as
are
a
going to
single
merge
cluster
it
will be
and then at the final
related to
stage
each other
we
in
are
that
going to get
particular
all the
cluster,
5 different
whereas
objects
it
in
will
a
be
single
different
set.
from the
So
other
this is
clusters.
agglomerative
So cluster
clustering.
analysis
Whereas
is
this
finding
divisive or
similarities between
diagonal
the data
clustering
according
is
to the characteristics found in the
it is
data
exactly the
and
reverse of this
grouping similar
agglomerative
data
method.
objects into
In this
clusters,
divisive
which means
clustering method,
we are going to have a
we'll
data
be
set.
considering a complete set
So
of
in
5
this data
objects
set, we are going to
which are
find the
further
similarities
divided into subsets
based on the
until we
characteristics.
get
If
single
we are
object
going to
in single
find any
cluster.
data which
This
is
is how
having
we
the
are going to have this
similarities based on the
agglomerative and diffusive
characteristics which we are
clustering.
considering,
So Agnes
then
or
we are
agglomerative
going to
nesting
make a
was
group
introduced
of
by
such
Kaufman and
data
Rasov in
and we are going to call
1990.
it as a single
This
cluster.
can be
Here,
implemented in
the data
statistical
which we are
packages like
choosing is
Plus.
of similar
This
kind.
uses
If they
a
are not
single link
similar,
method
like the
and the
data which we
dissimilarity
have selected
matrix.
is not having any
We are going to
similarities
merge the nodes
with the
that have the
characteristics
least
which we have
dissimilarity,
considered, then
and then
we are going
we
to
are going to
group it
ascend in
as
this
different
fashion in the same
clusters or
fashion
individual
recursively
clusters.
until we
This
get a
cluster
same
is
cluster. As you can see in
unsupervised
the
learning,
diagram there,
which means no
initially in the first
predefined
stage we
classes
have
are
different
available for
clusters
this. This
which are
unsupervised learning is
based on the
learning by
dissimilarity are being
observations.
grouped, and in the final stage you can see
Whereas
we have
the
only two
supervised
clusters
learning is learning
remaining,
by
which
examples.
consists
In
of all
supervised
the things.
learning, we are
So
going to
Diana
know
is the divisive
exactly
analysis
what input has to
which
be
is
given
introduced by the
and
Kaufman and
what will
Raja
be
in
the output of
1990
this
itself.
particular
So
input.
this is
When such
exactly the
things is
opposite
known
of
to
the
us, we
Agnes,
call it as supervised
implemented in
learning.
statistical
If
packages
that is
like
not
Plus.
known, that is, if the predefined
Eventually,
classes are
each
not
node
known to
forms
us,
a
we
cluster
are
on
going to
its
call
own.
it as unsupervised learning.
In this sense,
The typical
this works in the
applications of this
fashion of
cluster
descending
analysis
order.
are
We are
you
going to
can
have
use
a
this
set,
cluster
complete
analysis
set,
as a
which will
standalone
be
tool
further
to
divided
get the
into smaller
insight into
subsets
data distribution,
until and unless we
like
get a
as to
single
how the
object
data
in
has been
single cluster.
distributed or what is the
So the
similarities
next
which
thing is
can be found by the
density-based
data
clustering
set
methods.
and
Here,
so on. Or
clustering
you can
is
use
based
this
on
as
the
a
density
pre-processing
or
step
the
for another
local
algorithms.
cluster
So
criterion,
different
such as
algorithms will be
density,
there you can
that is
use as
called
a
as a connected point.
pre-processing step for it.
How each point is being
Hello
connected,
everyone. Today we are
or
going to
what is the
see what is
density of the
cluster
connection
analysis.
of the point.
Cluster
Based
is a
on this, we are
collection
going
of
to
data
have this
objects
density-based
similar to one
clustering
another
methods.
within the
So the
same
major
group
features
and
are
dissimilar to
discover
objects in the
clusters of
other group,
arbitrary
which
shape.
means it is a
It
collection of
handles
data
noise
objects which are related to
efficiently.
each other or
In
which
one
are
scan, we
similar
are
to
going to
each
get the
other
answers.
grouped as
Need
a single
density
cluster.
parameters as
These
termination
data
condition.
objects which have
So
been
these are the four
grouped as a
major
single
features of this
cluster will
density-based
be
clustering method.
related
Then
to
we
each
have
other in that particular cluster, whereas
this
it will be
basic concepts.
different from the other
Here,
clusters.
while doing this
So,
density-based
cluster
clustering, we need to
analysis
have two
is
parameters. One is
finding
EPS,
similarities between the
one is
data
mean
according
points.
to the
So
characteristics
EPS
found in the
is nothing
data
but the
and
maximum
grouping
radius
similar
of the
data objects
neighborhood.
into clusters,
Min points
which
is
means
minimum
we
number
are
of
going to
points
have
in
a
an
data set.
EPS
So,
neighborhood
in this
of that
data set,
point.
we are going to find the
Like n
similarities
EPS of
based on
P,
the
if we have
characteristics. If we are
n as
going
a
to
number,
find
or
any
EPS
data
of
which is
P,
having the
Q
similarities
belongs to
based on the
D such
characteristics which
that
we are considering,
distance of P,
then
Q
we
is
are
less
going to
than the
make
EPS.
a group
That
of
is,
such
distance of P,
data and we
Q
are going to call
is
it as
less
a
than
single
the
cluster.
maximum radius
Here,
of the
the
neighborhood.
data
If
which
that
we are
is the case,
choosing
then
is
we are
of
going to have
similar
this
kind. If
density-based
they are not
clustering.
similar,
So
like
we
the
have here
data which we have
directly
selected is not
density
having any
reachable.
similarities
A point P
with
is
the
directly
characteristics which
density
we have
reachable
considered,
from a point
then
Q
we are going to
with respect
group
to
it
EPS
as
and
different
min
clusters
points.
or
So we have two
individual
conditions, right?
clusters.
Two conditions
This
or two
cluster
parameters here.
is
Based on the
unsupervised learning,
EPS, which is the
which means
maximum
no
radius in the
predefined
neighborhood,
classes are available
and
for this.
minimum point,
This
which is
unsupervised
the minimum
learning
number of points in
is
the EPS
learning by
neighborhood of that particular
observations.
point. P and Q are two points.
Whereas the
If we are
supervised
going to
learning
consider
is
EPS and
learning
min
by
points of that,
examples. In supervised
then
learning,
we
we are
can
going
say
to know
that P is
exactly
directly
what input
density
has to be
reachable from a
given
point
and
Q.
what will be the output of this
As
particular
you can see in
input.
the diagram
When
here,
such things is known
P
to us,
can
we
be
call it
directly
as
density
supervised
reachable from a
learning.
point
If
Q
that is
if
not known, that is,
P
if the
belongs to
predefined
n
classes
EPS
are
of
not
Q,
known to us,
and
we are
core
going to
point
call it as
criterion would be
unsupervised learning.
mod of n
The
EPS of
typical
Q
applications of
is
this
greater
cluster
than of
analysis
min
are
points.
you can
If
use this cluster
this
analysis
condition
as a
has been
standalone
satisfied,
tool
then
to
we are
get the
going to have this
insight into
density
data
based
distribution,
cluster.
like as to how the data has been distributed or what is the
So
similarities
density
which
reachable
can be
and
found
density
by the
connected.
data
Here we
set
have two concepts
and
to
so
be
on.
thought
Or
of.
you can use
So
this as a
density reachable
pre-processing
and
step
density
for
connected.
another
What is this density
algorithms.
reachable?
So
Here
different
you can see
algorithms will be there. You
3
can
points
use as a
P, P1 and
pre-processing
Q.
step for
Here you
that.
can see P, O and
Hello
Q.
everyone.
So
Today we
density
are going to
reachable,
see
a
what is
point P
cluster
is density
analysis.
reachable from a point
Cluster
Q.
is a collection of
So
data
point
objects
P is
similar to one
density
another
reachable from a
within the
point
same group
Q
and
with
dissimilar
respect
to
to
objects in the
EPS,
other
which is
group,
the
which
maximum
means
radius of the
is a
neighborhood,
collection of
minimum
data
points in the
objects
maximum
which are
neighborhood, if
related
there
to
is a
each
chain
other
of points.
or which are
If there is
similar
a
to
chain
each
of
other
points which
grouped
runs
as a
from
single
P1 to
cluster.
Pn, wherein
These data
whereas
objects which have been
P1 equal
grouped
to
as a
Q,
single cluster
starting point
will
is
be
Q,
related to each other in
Pn
that
equal
particular
to P,
cluster,
end
whereas it
point
will
is
be
P,
different from the
such
other
that
clusters.
Pi plus 1
So,
is directly
cluster
density
analysis
reachable from Pi.
is
What is
finding
directly
similarities
density
between the
reachable? We
data
have
according to the
looked in
characteristics found in
other
the
slide
data
there.
and
So here,
grouping
if
similar
from a
data
point
objects into
Q
clusters,
to the point
which
P,
means
if we have
we are going to
direct
have
chain
a
of
data
cut
set.
points like P1, P2,
So
P3,
in this
P4,
data
P5
set, we are going to
till
find the
Pn,
similarities
and P1
based
is
on the
Q and
characteristics.
Pn
If we
is
are going to
P,
find any
if
data which is
Pi
having the
plus 1 is
similarities
directly
based on the
density reachable from
characteristics which we are
Pi,
considering,
we
then
call
we are going to
P
make
is
a group of
directly
such
reachable
data and we are going to
or
call it as a
density
single
reachable
cluster.
from a point
Here,
Q.
the data
What is
which we are
density
choosing
connected?
is
A
of
point
similar
P is
kind.
density
If they are
connected
not
to a
similar,
point Q
like
with
the
respect to
data which
EPS
I
we
have
have been pointed.
selected is
If
not
there
having
is a
any
point
similarities
O such
with the
that
characteristics
both P
which we
and
have
Q are
considered,
density reachable
then
from
we
O
are
with
going
respect
to
to EPS
group
and
it
been pointed.
as different
We need to have
clusters
a
or
point O here
individual
in the middle,
clusters. This cluster
which
is
is
unsupervised learning,
equal to
which
both
means
P and
no
Q,
predefined
or
classes are available
which
for
can
this.
be, which is
This
directly,
unsupervised
which
learning
is density
is
reachable from
learning by
point P
observation.
and point Q. If such case
Whereas
is there,
the
we call it as
supervised
density
learning is
connected.
learning by
From a
examples.
point P to
In
Q,
supervised
it
learning,
is
we
called,
are going
or
to
a
know
point P is
exactly
density
what
connected to
input
a
has to
point
be
Q.
given and
If
what will
there
be the
lies a
output of this
point O
particular
which is
input.
density
When such
reachable
things is
point,
known to us, we call
which
it
is a
as
density
supervised
reachable
learning.
point from
If
point
that is
P
not
and
known, that
point
is,
Q
if the
with respect
predefined
to
classes
EPS
are
and
not
mean
known to
points.
us, we are going to call it as
So now
unsupervised
we have
learning.
this DB
The
scan.
typical applications of
DB
this
scan is
cluster
density based
analysis are
spatial
you
clustering
can use this
of
cluster
application
analysis
with
as a
noise. This
standalone
relies
tool
on a
to
density
get the
based notion
insight
in the
into data
clusters.
distribution,
A cluster is defined
like
as a
as to
maximal
how
set
the
of
data
density
has been
connected points here.
distributed or what is the
Discovers clusters of
similarities which you can
arbitrary
be
shape with
found
the
by the
spatial
data sets
databases.
and so
So
on.
outliers
Or
will be
you
there.
can use this as
So
a
we have
pre-processing
borders, we
step
have
for
core.
another
So
algorithms.
if the
So
EPS and mean
different
points, or
algorithms will
if
be there
the
you can use as a
uh,
pre-processing step for that.
cluster is defined as a maximal set of density
Hello
connected
everyone.
points. If we
Today
have
we are
the
going to
maximum
see
set
what
of
is
density
cluster
connected points,
analysis.
this
Cluster
DB
is a
scan
collection
can be
of data
applied.
objects
This is
similar to
basically
one
on
another
spatial
within the
clustering
same
of
group
applications
and
with noise. Whenever
dissimilar
we
to
have
objects
noise
in the other
in the
group,
data set,
which means
we can
it is a collection of
have this
data objects
clustering
which
of
are
applications
related to each
with the
other
data
or
noise.
which are similar to